Hi guys, Mrs. Dan's here. So you know the drill. Copy the objective. We are multiplying polynomials, and there's two ways that we can multiply polynomials. A lot of students seem to like what we call the box method. Sometimes it's called the tabular method, and some students like the distributing method. The distributing method is kind of like, I guess, 1970s, 1980s way that we did it. I didn't even do the box method ever. And then I guess the box method is more of a recent thing. But you might have used this box method with simpler problems in elementary school, and maybe it makes it easier for you now when you're doing algebra. And uh, if you were in class, I would give you a chance to ask me any last minute questions before I gave you that quiz in class. Those of you at home know, I already answered your questions. You already took the in-class part of the quiz. You either already took the CASA Learning or you'll be doing it after this lesson. So let's go on with the lesson. We're going to do the do now together and the classwork together, and then we're done. So the do now. Really, I should ask you to maybe do it on your own and then check with me, so maybe you want to pause. I'm going to go for it right now. Remember, when the negative's not in parentheses, you have to be careful. This exponent only belongs to the 3, not the negative, so this answer is -9. This exponent belongs to the parenthesis, so this parenthesis gets multiplied by itself. Therefore, it's a -3 times -3, so that's a +9. This parenthesis gets multiplied by itself, so it's 2/3 times 2/3, which is a 4/9. This parenthesis is used as a factor 3 times, so I have x to the second times x to the second times x to the second. Maybe you know that answer already as x to the 6th. If not, we would expand this in here. X squared is x times x. X squared is x times x. X squared is x times x. Definitely x is being used as a factor 3 times. But now right here, x is now no longer called a factor. Factors, remember, are separated by multiplication signs. These are separated by plus signs. Therefore, these are now called terms. And when we're adding terms, we like to combine like terms. So combining is like adding or bringing together. How many x's are we bringing together? We have 3x. So you can't confuse multiplying with adding. So letter F, this is adding, right? See the plus sign? We did this in yesterday's lesson. We can't combine like terms until we get rid of the parentheses. The only way of getting rid of parentheses is by distributing what's in front. If you don't see the number in front, it means that there's a 1. So when you distribute, parentheses do go away. I'm left with 3x squared minus 2x plus 5x squared minus 4x. And now I can combine the like terms. X squares go with x squares. How many x squares do we have? Oh, we have 8 of them. X's go with x's. How many x's do we have? Oh, we have -6 of them. So our answer is 8x squared minus 6x. We have factors again, right? Exponents are repeated multiplication. The parenthesis is being used as a factor 3 times. We have 2x squared times 2x squared times 2x squared. You even heard me use the word times. And remember, in between this 2 and the x squared is a multiplication sign. I could expand this to be 2 times x times x times 2 times x times x times 2 times x times x. These are all factors. Factors are things that are multiplied together. I could use the commutative property with multiplication and rewrite this even if I wanted to. Now I'm just showing like a whole lot of work that maybe isn't necessary for you, but I just want to clear up any misconceptions. 2 times 2 times 2 is 8, right? 2 times 2 is 4, 4 times 2 is 8. x times x times x times x times x times x is x to the sixth. The final answer is 8x to the sixth. This is only one term. This thing I would call a monomial, right? In letter F, it had two terms. I would call it a binomial if we were to use our language that we learned in yesterday's lesson. H, there are no plus or minus signs. This is multiplication. There's a whole lot of factors here. This is 3 times x times negative 4 times x times x. No plus or minus signs. This is just a whole bunch of factors. I'm going to be left with a monomial for an answer. 3 times negative 4 is negative 12. X times x times x is x to the third. I have a monomial as an answer. But this, letter I, there's a minus sign right here. So it's like I have a negative 1 that I have to distribute. So if I distribute that negative 1 to those three terms inside the parentheses, I'm going to keep this x squared for now. I get negative 1x to the third plus 3x to the second minus 5. Remember, this negative is like changing all of those signs. These are all terms. So we don't expand it like what we do with multiplication. We combine it. We find like terms. Here's an x squared, and here's an x squared. How many x squares you have? 1 and 3. I have 4x squares. Here's an x to the third. Oh, there's nothing like that. Let me just write it down. Here's a negative 5. There's nothing like that. Let me just write it down. This turned out to be a polynomial that has three terms. Therefore, I could call it a trinomial. If they asked me to write my answer in standard form, I would get marked wrong right now. Remember, standard form means the exponents go from greatest to least. So I have to write this term first, negative 1x to the third. Then I write this term. That's positive, so I'm going to put plus 4x to the second. Finally, I write this term, minus 5. I don't need the 1 there. I do need the negative, though. I could write it as negative x to the third plus 4x to the second minus 5. This is my answer in standard form. This is mathematically equivalent. It's a good answer, but if they asked me for standard form, I'd get marked wrong. And then number 2, part A, it says use the diagram above to find the length of AB. They're only asking me for how long side AB is, from here all the way to here. How long is that? Well, I'm hoping that you definitely know that if from here to here is 30, and from here to here is 32, give you the answer. It means the whole length is 32, right? 30 plus 2 is 32. Really, I'm adding the two lengths together to know the total length. They only asked me for the length of side AB. And now I can find the area of ABCD, of this whole rectangle, because I can do 4 times 32, right? Area of a rectangle is length times width. So I get 128 square units, because I don't know what the units are. So if you know a length and a width, you just multiply the two. So I had to add those two segments first to help me find the total length. I have to tell you that there's another way we could have found the area. I really didn't have to find the total length of side AB, and this is what would be called the box method, because I have two boxes here. I can do the area of this rectangle right here, the smaller rectangle. 4 times 30 is 120. And then I can do the area of the other rectangle right here. 2 times 4 is 8. And if I add those two pieces together, the area of a total figure is equal to the area of its small divided pieces. So a 20 plus an 8, a 120 plus an 8, sorry, is still 128. So this is like the box method that I'm talking about. You can find the area of each individual piece and add it together to know your total area. We like to think about multiplication as like an area problem. So this is multiplication of a monomial times a binomial, and I could make a diagram to represent this. This one length here will be my monomial of 3. I will divide this. It doesn't matter where you put that dividing. This is just like for visual purposes. I can make this first piece this 4x squared, and I can make this second piece the x. Because if I add them together, I get the whole length, which is 4x squared plus x. Right? Just like in this do now, this whole length is 30 plus 2. So this whole length is 4x plus x. So if I divide it this way, I can find the area of each of those individual boxes, which is really just multiplying monomials, like what was on your quizzes even. So this would be a 12x squared, and this would be a 3x. So the whole thing is a 12x squared plus a 3x. Done. Now, usually, you guys maybe would want to distribute on this. So 3 times 4x squared is a 12x squared, and 3 times x is a 3x. Notice you get the same answer. So do you like the box method, or do you like the distributing method? Doesn't matter to me. When it gets complicated, I'm going to skip down to number 3 for a second. I'm only calling it complicated because there's more exponents and variables. Maybe the box method would be more helpful for you, right? Since this is a monomial, it goes on just this one piece. And since this is a trinomial, I have to break this top side into 3 pieces, which makes me break the box into 3 pieces. So I'll write the xy here, the negative 4x squared here, and the positive y here. And now I'm multiplying on the sides of this first box. The coefficient is a 3. X squared times x is an x to the third, and a y times a y is a y to the second. And then the next box, I'm just going to change my color. 3 times negative 4 is negative 12. X to the second times x to the second is x to the fourth, and I still have that y. And then the last piece is a 3. X squared, y times y is y squared. The answer is the sum of those pieces inside the boxes. So 3x to the third, y to the second, minus 12x to the fourth, y. And then since this is a positive, I put plus 3x to the second, y to the second. And that's your answer. So again, this is using the box method. Back in my day, we would distribute. You get the same answer though. 3x squared y times xy really is this 3x to the third, y to the second. You're going to see that I kind of tend to do distributive property because that's the way I'm used to. But I find that nowadays students tend to like the box method. So redraw it so that you get the right answer. Like the box method might be helpful here since it's a binomial times a binomial. Now, so far I've been doing a monomial times a binomial, and that's why this piece has been so short, right? Because there's only one term there. If I have two terms, the length of this box has to be divided into two pieces. So I could put an x and a -2. And then the length of this top part of the box has to be divided into two pieces. So I could put the x and the -5. So I took this first binomial and put it on the side, and I took the second binomial and put it along the top. Now find the area of each individual piece, and then we're going to add them. So x times x is x squared. I'll do this piece next. It really doesn't matter though. X times -5, we like to put the coefficient first, so I'm going to write it as -5x. And then -2 times x, I'll write it as -2x. And -2 times -5 is a +10. So remember, the answer is the sum of those pieces. I always start up here. I write the x squared. And then I just go across. So this is a -5x. Then I'll write this one -2x. Then I'll write this one +10. And when I write that, it looks like I have 4 terms, but I actually don't classify this as a polynomial. It really is a trinomial, and the reason why is because there's like terms right here. We don't classify our polynomial until we combine like terms. So the answer is x squared minus 7x plus 10. So this is my answer. It is standard form, and it is a trinomial. So box method probably is the easiest, because if I were to distribute this, what I do is I pretend, so I'm going to erase it, I pretend this isn't here. And I distribute like normal, and I write down x squared minus 5x. But remember, I was just pretending that that wasn't there, so I'm going to put it back. There really is a -2 here, but then you know what I pretend? I pretend this isn't here. So now I'm really distributing again. I'm going to draw my lines underneath so that they don't get confusing. -2 times x is -2x, and -2 times -5 is a +10. Remember, I was only pretending before, so I just need to put back what I erased. There really was an x here. But take a look at this step, and take a look at this step. Isn't it exactly the same? So when we're doing a binomial times a binomial, what happens is that there's just 2 times to distribute. I distribute with the first term here, and then I distribute with the second term. And it gives me 4 terms I combine to get down to that answer. So what do you like? Box method, distributing? Doesn't matter to me. So if we did number 5, I'm just going to give you the answer. No, I'm going to do the box method. I'm going to make my binomial, so I need 2 pieces here, and my trinomial, so I need 3 pieces up here. And I'm going to write this as x to the 4th, 2x to the 3rd, -5x squared, -x to the 3rd. Remember, this is like a -1. So this is a -2x squared, and then a +5x. I have to tell you that if you organize your box the way that I do, the like terms fall on like a diagonal. Do you see right here, x to the 3rd goes with x to the 3rd, x to the 2nd goes with x to the 2nd. So visually, you can kind of get your answer without writing out this in-between step that I did up here. I can write down this first, x to the 4th. I can combine these to get, remember this is like a -1, so it's a +1x to the 3rd. Then I can combine these, which will be a -7x to the 2nd, and then I write this down. So, like I said, a lot of students tend to like the box method. If we were to distribute, we distribute this first, and then we distribute this second, and we would really get 1, 2, 3, 4, 5, 6 things written down that combine to be this 4-term polynomial. And then I just want to do this last one. Bell's going to ring. I hope I can finish this before the bell rings. We have to find, what are we doing? Here, that's designing a frame. The frame is the same distance all the way around. Write an expression that represents the total area of the picture and the frame. So this is hard because I want to know right here what I'm drawing in blue. Okay, so I know from here to here, but I need to know the length from here to here. How long is that? So how long is this little piece in here? Oh, it says it right there. That little piece is an x. And how long is this little piece in here? Oh, it's x all the way around, right? So this is an x. So if we remember back to our do now, we put a plus sign in here to say 30 plus 2. So let's go down and put a plus sign right here and a plus sign right here. So this whole length is x plus 20 plus x. Don't you agree? I could simplify that to be 2x plus 20. The whole length of that side is a 2x plus 20. Therefore, the whole length of this side is x plus 16 plus x, which is a 2x plus 16. So I have a binomial times a binomial. I have to do 2x plus 20 times 2x plus 16. Now you can do this distributing if you're good at it, or now make your own box and do a 2x plus 20 over here and a 2x plus 16 here. Sorry, that's an x. We get 4x squared, 32x, 40x, and 320. So my answer is 4x squared plus 32x plus 40x plus 320. The middle terms combined, 4x squared plus 72x plus 320. And that is the area of the picture and the frame. We'll be doing more of these. Questions like this are on your test. So this is definitely something you have to know how to do. And there's a question like that on your homework. Please refer back to this question when you're doing your homework question. So don't forget to do that CASA learning also. And have a good day. See ya. Bye.